October 4th, 1992. El Al Flight 1862, a Boeing 747 on a cargo flight with 4 people on board, has taken off from Amsterdam Schiphol Airport, bound for Tel Aviv, Israel. Shortly after takeoff, the crew loses power from their number 3 and number 4 engines. Due to the asymmetric thrust, the plane begins to roll to the right, but the captain is able to counter the roll using the rudder. The crew declares an emergency and begins to circle back to land at Schiphol. Due to the emergency, the crew asks to land on runway 27, which has an unfavorable wind. However, the plane is too fast and too high to land, so they must make another descending circle in order to attempt to land. As the plane is slowing down and approaching the airport, the captain orders flaps and slats to be extended. The roll to the right gets worse and the captain is unable to fight it any longer. The plane plunges to the ground at a nearly 90-degree bank angle, directly hitting an 11-story apartment building. What happened to El Al 1862? Find out on this episode of Black Box Down. Hello, everyone. Welcome to Black Box Down. It's Gus and Chris. Hello, Chris. I'm sorry to start your day with such a bummer.
Oh, I know.
I heard you say, "Oh no."
Yeah, I was like, because it sounded like they were doing well, and I was like, they're gonna make it.
Yeah, obviously we're going to get into this. We're going to really dig into it. But yeah, man, it was so close. I think, after you hear the end result here, the big question is, could they have saved it? Could they have landed this?
Yeah.
And, we'll talk about that. We'll get into everything. I think the big tragedy here, people on social media have asked us about this incident quite a bit. Little plug for us. Follow us on Twitter and Instagram at Black Box Down Pod.
And Facebook.
Oh, and Facebook too. Facebook, that's right. Just because it's such a shocking incident, because it's a 747 that hits an 11-story apartment building. And since it's banking at 90 degrees, it's almost like it sliced through it.
Oh,
it's terrible, terrible tragedy that affected so many people. That based on the intro, what we're talking about, it seems like maybe it could have been saved, but again, we'll dig into that. So El Al 1862, like I said, was a cargo flight. So there weren't really any passengers on it aside from the crew. There was, the captain, the first officer, a flight engineer, and there was an airline employee who was, sitting in the jump seat as a passenger as well. So like a non-revenue passenger,
yeah.
It's just employees. It was scheduled to go from JFK in New York City to Tel Aviv, Israel, with a stop in Amsterdam, which is where we pick up this flight. They're going the final leg from Amsterdam to Tel Aviv on October 4th of 1992. The captain was Yitzhak Fuchs, who was 59 years old with 25,000 hours of flight time. First officer was Arnon Ohad, who was 32, had 4,288 hours of flight time. And the flight engineer was Gedalia Sofer, who was 61 years old with 26,000 hours of flight time. So obviously, tons of experience between the three of them. The first officer's the most junior by far with over 4,000 hours. The captain and flight engineer have over 25,000 hours each, which is a ton, right?
Yeah.
Very experienced. The aircraft itself was a 13-year-old Boeing 747 with 45,746 flight hours and 10,107 cycles. So it was experienced too. Not like super old, but it was an experienced plane. It knew what it was doing.
But not experienced like old experience, like bad experienced.
Yeah, no, it was good. It was good. 13 years old. 13 years old is not super old, for an aircraft.
They're kind of like cats, right?
Go on.
Yeah, cats can live to be around, 20 years old before they, right?
Okay. I was wondering where you were going with that.
Right? I mean, I feel like that's around whenever planes start getting old, is like 20 years.
Yeah, I mean, sure, I'll go with that. It's actually an interesting question, right? You start to wonder, how old are fleets? And, based over the past 2 decades, more or less, the average age worldwide of an air transport jet fleet is between 10 and 12 years old. Of course, it can vary wildly. Here in the United States, it varies quite a bit. I think I looked it up while we were talking here. From what I can see, the youngest fleet is Spirit Airlines at 6.6 years average age for a plane. And the oldest is Allegiant at 19.8 years. This is as of 2017, by the way. So it changes a little bit.
Okay.
And then the airlines that you think of as like flagship airlines, American Airlines at 10.8 years, United Airlines at 14.3 years, Delta at 17 years. Of course, this information is a couple years old, so it changes a little bit. But just to give you a rough idea of the average age of airline fleets.
Yeah. But that falls in the cat range.
It falls in the cat range. Fair enough.
Sorry, that was a tangent about... Anyway, back to the
the incident. So then, like I mentioned, there was one passenger on board who was an airline employee, who was a 23-year-old Anat Solomon, who was an El Al employee, who was actually flying back to Tel Aviv to get married to another El Al employee.
Oh.
Yeah, so awful for them. This particular flight, this plane, like we said, it came from New York's JFK Airport initially. It landed in Amsterdam at 1:40 p.m. Universal Time and was scheduled to depart at 4:30, but received an air traffic control slot time of 5:20. So they were not quite an hour delayed, 50 minutes delayed.
Mm-hmm.
Maintenance transit check was carried out, aircraft was refueled, and the flight crew boarded the plane in Amsterdam. The captain requested pushback at 5:04, and the crew began to taxi at 5:14. The takeoff roll started at 5:21 p.m., again, Universal Time, and the crew departed in an eastward direction with no anomalies evident during the initial climb. Then at 5:27, which is 6 minutes after their takeoff roll started, the aircraft was passing through 6,500 feet. The numbers 3 and 4 engines suddenly lost all power.
Whoa.
So yeah, they just, the flight engineer reports, number 3, number 4 engine, no power. And, like we've talked about before in previous incidents, they develop asymmetric thrust since number 3 and number 4 engine are on the right side. Their only remaining working engines are on the left side. So,
yeah.
They start to roll to the right because of it. So they kind of, got to fight that. And we talked about that in the intro. They declare a mayday and they started a right turn as air traffic control asked if they wanted to return to the airport. The crew confirmed it and reported a fire in the number 3 engine and a loss of thrust for number 3 and number 4. The crew was instructed to turn to heading 260. They were informed that runway 06 was in use, but the crew requested the use of runway 27 instead. I don't remember which runway they took off. I think they took off from 06. They definitely did not take off from 27. But 27 at Schiphol at the time, 27 was the longest runway. So they wanted to use that one, even though the winds were unfavorable.
They're just going to be coming in fast and hard and as much.
Right. They've got, they still have a ton of fuel. They really haven't gone very far. They want to make sure, because of the emergency, they have as much space to stop as possible. At about 5:30, the plane was 7 miles from the airport at 5,000 feet. They were too high for a straight-in approach, so the crew were instructed to turn right to a heading of 360 and descend to 2,000. So they were, still really fast, really high. Mm-hmm. They weren't going to be able to land it, so they need to kind of do like a circle, lose some more altitude, slow down a bit, and then come in to try to line up and land. About a minute later, the controller asked what distance they required for an approach, and the crew said they needed 12 miles final for landing. The crew then set the flaps to the first position. Air traffic control then instructed the crew to turn right to heading 100 and asked about the status of the aircraft. The crew replied saying that the number 3 and 4 engine were out and they were having problems with the flaps. At this point, the flight was at an altitude of 4,000 feet with a ground speed of about 260 knots on a 120 heading.
That's really fast.
It's pretty fast, yeah.
If memory serves me correctly, which it probably won't, they should be getting like 130 coming in?
Yeah, I mean, a little higher than that. I think a 747 typically wants to land around 145 knots.
Okay.
You're close. I mean, they're about double the speed they need to be. But they're still circling, they're not on final yet. So they're shedding their speed, but they're still too fast. So after this, they're instructed to turn right to a heading of 270 to intercept the final approach course. And of course, 270 would put them directly in line with runway 27. The flight was about 3 nautical miles north of the center line and about 11 miles out, and it became apparent to air traffic control that the flight would overshoot the localizer. And the localizer is just a horizontal guidance system for instrument landing. So they were, they weren't quite lined up correctly to come in on their approach. The crew was informed of this and directed to turn to 290 degrees in an attempt to intercept the final approach again, but from the south. 20 seconds later, they were instructed to fly 310 degrees, and they were cleared to descend to 1,500 feet. The flight crew acknowledged this instruction at 5:35 and said they had a controlling problem. About 25 seconds later, the first officer called out, "Going down, 1862 going down." And the final part of the transmission, commands from the captain to raise all flaps and lower the landing gear could be heard. The stick shaker and ground proximity warning system could also be heard during the transmission. And at 5:35 and 42 seconds, Flight 1862 crashed into an 11th-floor apartment building in the Bijlmermeer suburb of Amsterdam, about 8 miles east of the airport. The impact centered at the apex of 2 connected and angled block of the apartments, and fragments of the aircraft and building were scattered over a 400 by 600 meter area. The aircraft was destroyed by the impact and fire, and everyone on board was killed. There were 11 serious and 15 minor injuries from people on the ground. The police originally estimated a death toll of over 200 people on the ground, and the Amsterdam mayor said that 240 people were missing. However, in the end, the official number in the report is that 43 people on the ground were killed. But many people believe this number is actually much higher.
I would have guessed a lot higher if you told me a plane hit an 11-story building.
Right. What do we say? At 5:35, it's typically after normal work hours. You would think that it would be higher than that. And one of the reasons people say that it's actually probably higher is the building had a large number of undocumented immigrants living in it.
Oh.
And many of the immigrants were from Ghana, Suriname, and members of the Ghanaian community stated they had lost a considerable number of undocumented occupants who were not counted among the dead.
That's terrible.
Yeah, the official report's 43, but the reality is it probably was actually much higher. So there's a lot going on here. Obviously we're going to get into the investigation here in just a second, but just to kind of recap, they're taking off, everything's fine. They lose their number 3 and number 4 engine, have to circle to come back to the airport, going to land in an unfavorable direction. When they were lined up for 27, I believe that they had like a quartering tailwind, which would have pushed them and made their ground speed faster and would have made them take longer to stop on the ground. When they're coming in, they're deploying their flaps and slats, lose control, can't fight the bank anymore, plane banks to the right, and they hit an apartment building. Any thoughts before we get into the investigation?
As to what caused it?
Yeah, what do you think? Just like in general, based on what you know so far. It doesn't necessarily have to be what caused it, but do you have any suspicions about why they lost control, what may have happened to this plane? Just because, obviously, we've talked about this many times. I'm not a pilot. You're not a pilot. I just like plane crash investigations. But, we've been doing this for a while now, and I feel like lately, you knew more or less what the landing speed of the 747 was, which is really impressive considering, where we started 2 years ago, Chris. So I'm just curious, where your head is so far in listening to this.
When they put the flaps down, did it only go down on one of the wings?
Interesting idea, right? Why did that happen? Yeah. I was curious to see if that might be something you said. Well, we're gonna dig into it. It was just a little thought starter. So the investigation was carried out by the Netherlands Aviation Safety Board. And it was discovered that the number 3 and number 4 engines were not found in the main wreckage.
Not found?
Nope, they weren't there. Several parts of the leading edge flaps and leading edge structure on the right wing were recovered on land along the original flight path. The top skin panel above the number 3 engine pylon showed extensive chafing from the pylon structure, and smaller parts of the leading edge flaps and wing structure were found in the same area.
So there were no flaps or engines.
Maybe not, right? Where are they? So they also found a slightly damaged 2-meter-long pneumatic duct of the bleed air system in that area, and this part's normally located in the wing leading edge between engines 3 and 4. A little east of this area, the number 3 and 4 engine were found in a lake near the entrance of Naarden Harbor. The engines were dredged from the lake with the pylons and many parts of their nose cowls and thrust reversers. The significant damage to the engines was external and occurred when the engines hit the water. Internal rub marks and other witness remarks indicated that when the engines hit the water, they were either at a low rotating speed or had stopped. Internal examination of the engines showed no abnormal signs of pre-existing damage. Significant fan blade tip rubbing was found at 2 places in the fan cases of the engines. And this kind of damage is typical of fan blade tip rubbing when the engines are at a high speed of rotation. In this case, the location of the rub within the fan case indicated a gyroscopic effect of the engine rotating parts such as the fan, compressor, and turbine discs at engine separation. So that just kind of tells you the engines were running, and they were running at high speed when they became detached from the plane. So it's not like they failed and then fell off or something. It's like they were running at high speed, and then engines number 3 and 4 just separated.
They just fell out of the plane, or is that?
They kind of, it almost seems like they were ripped off because, rather violently, because parts of the leading edge of the wing were also missing, like tubing. It's parts that should be in the wing on the leading edge were also ripped out as well.
And this just happened in the middle of the flight.
Right, just after takeoff. So what they determined was that when the flight reached an altitude of 6,500 feet, the number 3 pylon, and we've talked about the pylon is the part of the plane where the engine attaches to the wing. It's like when you see, the engine hanging down, the part that's actually holding it connected to the wing, that's the pylon. So they determined the number 3 pylon failed, causing it and the number 3 engine to separate from the plane. And as they separated, they collided with the number 4 pylon and engine, which made them separate as well. So it's like the number 3 engine, the pylon failed, it fell off, then it went to the right and hit the number 4 engine so hard that it fell off as well.
Oh my God. it just fell off. And then
Right. And then, when it fell off, it also ripped out
Yeah.
parts of the leading edge and parts of the wing with it as well. And when the engine separated from the aircraft, the number 3 and number 4 hydraulic systems were severely damaged as well. And we've talked about this before. There's, I believe, 4 different hydraulic systems on the 747. And due to the severe damage, the number 3 and number 4 hydraulic systems ceased operation, and consequently, the hydraulic pressure was not available to the relevant flight controls and other systems. There was also damage to the fire detection loops after the engine separation that resulted in electrical, shorts, which caused the fault indicators and subsequent fire warnings. So even though, the fire warnings went off in the cockpit, there was no fire because there was no engine.
Yeah. That
It's like, how can you, the engine's not there. There's no way they could have had a fire. It was just, electrical shorts and malfunctions because the engines were ripped off. So, when they deployed the fire extinguisher in the we didn't cover this, but when they deployed the fire extinguishers, in the cockpit, the alarm still stayed on.
Yeah.
Which, shouldn't happen.
This is not a good analogy, but it made me think of it. Is, how sometimes when people lose a limb, they have like false limb pains?
Yeah, I can see that. Yeah.
It's like that. Like it doesn't have.
Yeah. It's like a false fire pain.
Yeah.
So the crew reported the fire warning in engine number 3. It is not known if the engine fire warning continued during the remainder of the flight, nor if the bottle discharge light was illuminating the cockpit, but there was no indication of an actual fire on board the aircraft. So like when the investigators go through all of the recovered pieces, they can tell there was no fire on the aircraft.
Mm-hmm.
The board concluded that the separation of the number 3 engine pylon was caused by a failure of connecting components that attached the pylon to the wing of the airplane. The board thought of 9 scenarios that would lead to this happening, and of the 9, 6 of them were quickly dismissed, leaving 3 possibilities.
Okay, good investigative work.
Right. Yeah, just like trying to narrow it down, figure out all the different possibilities. So the 3 possibilities are, and they're going to sound a little confusing, but we're going to go into some explanation of what they all mean here. So the 3 possibilities. The first one is upper link pin fracture or disconnection. The second one is inboard mid-spar fitting pin fracture or disconnection. And the third one is outboard mid-spar fitting pin fracture or disconnection. I'm sure you can tell. There's a pattern in these. It's somewhere there's a pin that was either fractured or disconnected. One of 3.
Just a pin.
Yeah, well, link pin. So, I mean, it sounds small, but these things are huge.
Okay.
They're actually really big components. So, as the upper part of the upper link and corresponding fitting was not recovered, the question arose whether or not this link was properly attached at the time of separation. By means of stress analysis, it was shown that the fracture of the upper link in the noted bending torsion mode could only have occurred if the wing end pin was in place and intact. Scenario 1 could therefore be eliminated. The approach taken for further evaluation of the remaining 2 scenarios was one of deduction, augmented with stress and load analysis. So using this approach, it could be proven that a separation initiated by a failure in the outboard mid-spar fitting was highly improbable. The inboard mid-spar fitting was recovered. The outer lug of the inboard fitting had fractured with a segment of the lug missing. This lug fracture was determined to be ductile and appears to have resulted primarily from tension and to a lesser extent from lateral bending. The ductile failure can only be explained if it was eccentrically loaded. For this to occur, the inboard shear face of the fuse pin must have sheared first in order to subject the lug to an eccentric load. As there is no service evidence that the El Al airplane experienced a static overload preceding the accident, it is assumed that the inboard shear face of the fuse pin was initially fatigued and then failed under normal flight conditions. So we'll go ahead, we're talking about pins and, lugs and links. I'll go ahead and look up photos of these and post them on our social media so you can see exactly what they look like. Mm-hmm. But essentially what we're getting at here is that like part of this fastener became fatigued and sheared over time, from load, and then it just eventually it failed, and then it was no longer supporting the engine properly, which caused it to separate.
And that it's just normal wear and tear, but that doesn't sound normal, right?
Right. These things should be designed to hold it. So, obviously now the question is, why did it fail? Is this a problem they need to worry about with other planes, or was this like a one-off issue that was just, was this just not manufactured correctly? We talked about an incident several episodes ago where counterfeit parts that weren't as strong failed, leading to a plane crash. So now, that's where they're like, okay, we know that this particular pin, these particular lugs, like this part of the plane failed. Why did it fail? Is this a problem inherent to the design, or was it a specific problem to this very specific piece of hardware?
Yeah.
There's tons of worthwhile goals to set for yourself this year. Personally, learning a new language with Babbel is at the top of my list. Babbel is the addictively fun, fast, easy language learning app that has sold more than 10 million subscriptions. I don't know if I've talked about it on this podcast. I think language is really interesting. I try to pick up a little bit of languages here and there. I grew up learning Spanish, but I never formally learned it. So I picked Spanish or Latin American Spanish in Babbel. And like trying to brush up and learn the way it actually all the rules for the language and the way it should be spoken. It's really interesting. I really like it. I've learned that I've been saying some things wrong. So it's good to have an outside perspective, a third party in my case. But it seems like it's all really straightforward, really easy to learn. It's super fun to learn a new skill and, slowly get better at it and master it. Anyway, Babbel's 15-minute lessons make it the perfect way to learn a new language on the go. Other language learning apps use AI for their lessons plans, but Babbel's lessons were created by over 100 language experts. Their teaching method has been scientifically proven to be effective, and you can choose from 14 different languages like Spanish, French, Italian, German. Plus, Babbel's speech recognition technology helps you to improve your pronunciation and accent. Right now, when you purchase a 3-month Babbel subscription, you get an additional 3 months for free. That's 6 months for the price of 3. Just go to Babbel.com, use promo code BlackBoxDown. That's BABBEL.com, code BlackBoxDown. Babbel, language for life. For a lot of us, New Year means rethinking how we take care of ourselves. Native makes it easy to switch to a personal care brand that cares about you by making all their products with simple ingredients. Native is all about stopping the stink the right way. That's the Native difference, which is why Native is on a mission to overhaul your entire hygiene routine. They started with their customer favorite coconut and vanilla aluminum-free deodorant. Now they're moving on to other good stuff like body wash, bar soap, toothpaste, shampoo, conditioner, sunscreen. Their products are created with simple ingredients you can actually recognize, like shea butter, coconut oil, so you can smell great all day long. Native deodorant checks all the boxes: aluminum-free, 24-hour odor protection, zero residue on skin, over 10 scents to choose from. I'm really picky with my deodorant. With some deodorants, I have allergic reactions. I have to be very selective about the ones I use. Native has been great. Really love it. Like I say, I like all the natural ingredients, and I like that it works great for me. So anyway, this year, up your personal hygiene routine with Native. Go to nativedeo.com/blackboxdown or use promo code blackboxdown at checkout. Get 20% off your first order. That's nativedeo.com/blackboxdown or use promo code blackboxdown at checkout for 20% off your first order. So, of course, they do metallurgic studies on the inboard mid-spar fitting lug, and it was determined that in all probability, the lug fractured and failed by overload under a combination of bending and tensile loads. And of course, they say here, in all probability, and they need to say that because the fracture surface details had been almost completely destroyed by corrosion as a consequence of the immersion in the water. Checks of the lug material showed that it met the requirement. So this is the important part, right? Checks of the lug material showed that it met the requirements of hardness, tensile strength, and chemistry. Metallurgic studies were also done on the outboard mid-spar fuse pin, and these showed that there was a large fatigue crack that was present at the outboard location of the minimum wall thickness of the fuse pin. This fatigue crack was up to 4 millimeters in depth and encompassed about 50% of the inside circumference. The fatigue crack had developed from multiple initiation sites along poor quality machining grooves. There was no evidence of corrosion pitting that could have contributed to fatigue initiation. The material of the fuse pin met the chemistry specifications. However, the hardness measurements indicated a tensile strength of 117 KSI, which is lower than the specified range of 126 to 139. So, they're going through the process and, they're seeing like, well, it meets all of the requirements it should have been. That being said, the remaining pins also have a failure and they're not quite they don't have the indicated tensile strength that they should. They're a little below where they should be. Mm-hmm. It should be noted that low hardness does not mean the pin was under strength, because sometimes the final machining cut is adjusted based on the testing conducted in the sampling process. So they're like, this might be within the specifications. So Boeing also did an investigation because, Boeing makes a 747, and they investigated this fuse pin. They determined that at the time of the last inspection, which was 257 flights before this incident, the fatigue crack would have been at a depth of 0.14 inches. The ultrasonic reference depth used to inspect these parts is 0.085, so the crack should have been detectable. Mm-hmm. El Al, however, contests the Boeing findings regarding the crack growth data. El Al, who of course is the operator of this plane, is of the opinion that the redistribution of loads after the initial failure in the inboard mid-spar fitting lug resulted in significant increase in crack growth rate during the number of flights, and is therefore conceivable that the crack was of less than the detectable length at the last ultrasonic inspection. So Boeing says at the last inspection, this crack should have been detected. LL says, no, this crack probably grew super fast.
At the end, because, yeah.
Right, as it gets worse, and it was probably not detectable. Of course, LL's going to want to say, they're incented to say that they couldn't have detected this.
But is this a common problem?
So, was this a common problem? I mean, that's a good question. I don't think we've covered any other incidents like this.
Yeah.
We have covered, what was it? A flight that left Chicago and lost an engine on takeoff after they think they left Chicago O'Hare. What was that? That was American 191. That being said, that was a McDonnell Douglas DC-10. That was not a 747.
Yeah.
So we have covered an incident similar where, a plane physically loses an engine, like it falls off the plane. But I wouldn't say it's something that's super common. And if you remember in that incident, it's because when they maintained the engine, they were taking it off and putting it back on incorrectly, causing damage.
I remember now. They didn't fully support it whenever they took it, or they were doing...
Right. They were using a forklift.
That's right, yeah.
So, that being said, even though we don't really cover incidents like this, it's not really a super common thing. Despite that, the pylons on the 747 are designed to break cleanly away from the wing in case this happens. They want to make these planes as safe as possible. So, they do plan for these kinds of scenarios. And they based this design, it was on a similar fuse pin design from the Boeing 707, which is an older plane. Boeing concluded that the fuse pylon concept effectively protected wing structure and fuel tanks against the consequences of pylon overload. A detailed failsafe analysis of this nacelle and pylon concept was made by Boeing, and the nacelle is just like the engine housing. It's like the outer part that you see. This analysis addressed all critical load conditions resulting from abnormal flight or landing conditions. It's important to note that during type certification, a then state-of-the-art fatigue analysis of the pylon structure was performed by Boeing in order to establish the maintenance requirements for the Boeing 747. In real life, this didn't turn out to be sufficiently reliable. At that time, full-scale testing was not part of the United States airplane certification process, and Boeing did not conduct any structural testing of the pylon to positively determine its static strength, fatigue, and fail-safe characteristics. The FAA accepted Boeing's contention that since the Boeing 707 pylon had proved reliable, the nearly identical design of the Boeing 747 pylon would also be reliable.
Oh.
So, and this is the kind of thing we've talked about before. It's not exactly the same thing, but this is a recurring problem that we still face today in the industry, where the FAA will take the manufacturer's word for something. Boeing says, well, the 707 was safe. This is pretty much the same thing. This will be safe too. The FAA just says, yeah, all right, okay, that's fine. We kind of talked about this with the 737 MAX and the MCAS system. We talked about this when the DC-10 had problems with its cargo door, and McDonnell Douglas told the FAA, "Don't worry about it." Had the gentleman's agreement we discussed, like, "Don't worry about it, we'll take care of it." The FAA kind of just drops the ball on oversight in these instances. Anyway, getting a little tangent there. Going back to the 747 and 707, like we said, they kind of said since the 707 was safe, the 747 should be safe. So therefore, on the date of type certification, the nacelle and pylon design met all applicable airworthiness requirements. The FAA issued a large number of airworthiness directives addressing numerous fatigue problems in the pylon structure, including fuse pins, lugs, and fittings. Nevertheless, new cracks and failures were discovered frequently, raising doubts about the ultimate strength of the structure. The original design, together with the continuous airworthiness measures and associated inspection system, did not guarantee the minimum required level of safety of the Boeing 747 at the time of the accident. So what that's getting at is that even though there were no other incidents or no other real instances of things like this happening, there were ongoing problems and ongoing issues here.
And there might be in the future.
Right. And I think that's the important line there at the end. This did not guarantee the minimum required level of safety of the Boeing 747 at the time of the accident. So, yeah, they obviously things needed to be changed and something needed to be done here. The board also had some notes about air traffic control. They said the exchange of information was at times inadequate. The crew only gave sparse information concerning their problems and intentions. The controller occasionally used non-standard phraseology, which was not as explicit or as understandable as would be desirable in emergency situations.
Okay.
In these situations, crew most certainly are working under extreme workload conditions, and the controllers may feel reluctant to interfere with the crew involved in an emergency. However, pilots and air traffic control personnel should be aware that for adequate handling of an emergency, it's vital to use standard phraseology and to exchange all necessary information about the urgency and severity of the situation. Air traffic control was confronted with the unexpected intention of the crew to land on runway 27 instead of the runway in use, which was 06, which the crew initially was directed to. The attempt of the controller to position the airplane by radar vectoring to a point 12 nautical miles on the localizer for runway 27 was not completely successful. We talked about that. They kept getting redirected a little bit to try to line back up on the localizer.
Mm-hmm.
A wider than normal setup of the circuit would have been better allowed for the possible steering errors and slow reactions to the heading changes which occurred and which may be expected in emergency situations. During the procedure to vector the airplane for runway 27, it flew over the city of Amsterdam. The board is fully aware of the responsibility and authority of the captain of an airplane in distress. The board also realizes that after the declaration of emergency, air traffic control recognizes as its main task the assistance of the crew in its efforts to recover the airplane. However, the board feels that in the handling of emergency situations, not only the safety of airplanes and passengers, but also the possible risk of third parties should be taken into account. So that was not a good thing that they vectored and flew the airplane over Amsterdam while having an emergency. Normally, they want to take it somewhere where there's less population in case the plane does crash so that you don't have people on the ground injured by an incident like this. And we've talked about other incidents where, pilots try to fly a plane away from houses and away from populated areas if they know they're going down because they don't want people on the ground to get hurt. They want to try to minimize people injured and people killed in these incidents.
Yeah.
There's also, this is more like armchair analysis kind of thing. So, obviously I'm not a pilot. I was not involved in this incident. But sometimes in incidents, and we talked about this specifically with Qantas 32. Remember that was an Airbus A380 that lost an engine after they took off from Singapore.
Mm-hmm.
They had to try to figure out the engine was still attached. It just wasn't functioning anymore. And they had to figure out what was going on. If you remember in that incident, the captain stayed out. He stayed in a holding pattern over the ocean, and they went through testing the plane systems. Like, how far can we bank? What can we do? How is the plane responding? And then they're like, okay, now that we know what the plane's capable of, we're going to take it back in and land it. There's an argument to be made that maybe the crew should have, flown the plane out a little bit, tested it, and then tried to bring it in for a landing.
It's scary to think that, though, because they're like, we got to land as soon as possible. The plane is literally falling apart.
But they don't know that.
Yeah.
All they know is that they don't have their number 3 and number 4 engine. That's not providing thrust.
They probably thought it was a fire.
Right. They might have thought there was just an engine fire. And of course, if the fire notification's on, they will want to land it as quickly as possible because, onboard fire is terrible. There's no way to fight that. So, there's a little bit, that maybe they could have done differently there, but it's really hard to say.
Yeah.
So we'll go through the findings right now. So at an altitude of about 6,500 feet, the number 3 pylon failed. This pylon and the number 3 engine separated from the right wing. The number 3 engine struck the number 4 engine, causing the number 4 pylon to separate from the wing. The leading edge flaps and portion of the fixed leading edge of the wings back to the front spar were extensively damaged. The number 3 and number 4 hydraulic systems were completely disabled, and pneumatic system was partially disabled. So that's just summarizing.
Mm-hmm.
Number 3 and number 4 engine fell off and really damaged the right wing and disabled the number 3 and number 4 hydraulic systems. The flight crew reported a fire on the number 3 engine to air traffic control. Given the system logic, a fire warning may have been the result of a double fault indication of the system. So there was no actual fire because there was no engine. It was just a fault of the system.
Mm-hmm.
Well, I guess it was detecting an error, and there's no engine missing light. So engine fire pops up. So then I think this next finding leads to a question people might have, like, couldn't they just look and see if the engines were missing? Well, the next finding says, due to the limited field of view from the cockpit to the wing area, the flight crew was not able to observe the separation of the number 3 engine nor the damage to the wing. So there's no way they could have seen it from the cockpit.
Well, there weren't passengers.
Right. There were no passengers, so there's no way to see. Or there was nobody, there was nobody back there to see. Performance and controllability were so severely limited that the airplane was marginally flyable. Current standard industry training requirements and procedures do not cover complex emergencies like those encountered by LL 1862. During preparation for the final approach, speed reduction was the airplane exceeding the limits of its remaining control capability. The airplane crashed into an apartment complex. So because they reduced their speed and they were getting less lift, that really exacerbated the problems that they were having. Because on top of asymmetric thrust, the left wing, since it's still in one piece and still operating correctly, it's generating way more lift than the right wing, which is damaged. So when they slow down, like that right wing's going to start to droop even more. And then, of course, I don't want to get ahead of myself. So yeah, that's what this line is saying. You know, when they slow down, that left wing that still has the correct shape begins producing even more lift, which, you know, causes they can't fight that roll anymore.
So it's the only way to have landed to have just gone in really, really fast and landed. They've landed that first time when they were going in too fast.
Well, then, I mean, I don't know if that's survivable either. I guess, you know, if you want to look on the bright side, if they managed to come in really fast and put it on the ground on the runway, they wouldn't have hit the apartment. You know, that's maybe the bright side. But then, you know, who knows what they would have hit at the airport if anybody would have been hurt or killed there. You know, I think if they had to come in, what do we say they were at that point? Like 260, 300 knots, like somewhere in that range. I don't think they could have stopped, especially if, you know, with the amount of fuel that they still had and all the cargo.
Oh,
the brakes might not have been sufficient to stop that plane, even at runway 27, especially considering on top of all of that, they also would have had a tailwind pushing them down. I mean,
and their reverse thrusters would have only been on one wing.
Right. I mean, there's just so much that's wrong.
Would that have made what would that have done if there were only reverse thrusters on one wing like that?
They would be pushing back on that side. It may have caused them to like turn. I think it may have caused them to turn to the left, actually, since there's no reverse. Like it's like you're hitting the brakes on the left side.
Yeah. It's like backwards.
Right. So yeah, I don't know. They could have tried it, but they didn't know that that's something that they would have encountered.
Yeah.
Well, anyway, back to the findings here. Exchange of information between LL 1862 and air traffic control was not always adequate. The effectiveness of the fused pylon concept in protecting the wing structure and fuel tanks against the consequences of pylon overloads was based on the history of similar fuse pin designs of the Boeing 707. Certification of the Boeing 747 pylon included a fail-safe analysis of the nacelle and pylon concept. At the time, this analysis did not address specific fail-safe requirement, assuming a fatigue failure or partial failure of a single structural element. Inspection analysis on recovered vital parts of the pylon construction revealed severe damage due to fatigue. No firm conclusion could be drawn whether or not the fatigue crack in the outboard mid-spar fuse pin was detectable at the last ultrasonic inspection. So, you know, even though Boeing said it should have been detectable, LL said it wasn't, so they couldn't say definitively whether or not it actually was. After analyzing the possibilities, it is assumed that the separation was initiated by a fatigue crack in the inboard shear face of the fuse pin in the inboard mid-spar fitting. Over a period of 15 months, 3 pylons have failed in flight, resulting in 2 fatal and 1 serious accident. The original type designed together with the continuous airworthiness measures and associated inspection system did not guarantee the minimum required level of safety of the Boeing 747. So I'm going to walk back something that I said earlier. And I said that we really hadn't talked about many incidents like this. I mean, I guess there were a couple of incidents. We might not end up covering in this show just because they're pretty cut and dry. But there was another flight that did also lose a pylon shortly after takeoff. It was also a cargo flight. So, I mean, it did happen. It wasn't super common because 747 was flown quite a bit.
Yeah.
But it was, you know, it was enough to raise concerns. So the design and certification of the Boeing 747 pylon was found to be inadequate to provide the level of safety that was required. Furthermore, the system to ensure structural integrity by inspection failed. So, right, it's like one of the things they're supposed to do is during, you know, regular inspections to make sure everything's safe. And that failed also.
Yeah.
This ultimately caused, probably initiated by a fatigue in the inboard mid-spar fuse pin, the number 3 pylon and engine to separate from the wing in such a way the number 4 pylon and engine were torn off. Part of the leading edge of the wing was damaged, and the use of several systems was lost or limited. This subsequently left the flight crew with very limited control of the airplane. Because of the marginal controllability, a safe landing became highly improbable, if not virtually impossible. So even here, the report says landing this would have been, their words, virtually impossible.
Wow.
Like I said, even if they managed to get it on the ground, I don't know that they would have been able to keep that plane together. This seems crazy to me that to even try to do it. But the fact that they held it together for so long, you know, is commendable. I think it's a testament to how experienced the entire crew was, especially the captain, who really did have a lot of experience. That being said, still probably the wrong call to fly over Amsterdam because, you know, they ended up hitting the apartment. So, of course, you know, there are recommendations as a result of this. The first one, of course, is to redesign the Boeing 747 pylon structure, including attachment to the engine and wing. So this is something you do not have, you really can't fly the 747 anymore. But after this incident, this is not something you have to worry about anymore. They redesigned it. They just totally redid it. And the redesign program for the pylon should include a full-scale fatigue and fail-safe test. So redesign, test it like crazy to make sure that it actually works correctly. A large-scale in-flight, fleet-wide fatigue load measurement program should be carried out, both on the wing, fuselage, and fin-mounted engines in order to establish more realistic load spectra for fatigue evaluations. So just test everything everywhere, all the planes that are out there. Review present methods of controlling structural integrity, such as non-destructive inspection techniques and airworthiness directive requirements in the current design, Boeing 747 Pylon assembly. If a structural design concept is used as the basis for the certification of another design, in-service safety problems for both designs should be cross-referenced.
Yeah.
So yeah, this like, let's make sure if someone tries this again that we think about it. That's not just like rubber stamp because it was already approved once in another plane.
Yeah.
Evaluate and, where necessary, improve the training and knowledge of flight crews concerning factors affecting aircraft control when flying in asymmetrical conditions, such as with one or more engines inoperative, including advantages and disadvantages of direction of turn, limitation of bank, and use of thrust in order to maintain controllability. So, when things are asymmetric, you're going to want to favor turning in one direction versus another. You're not going to want to bank very much. So just like really drive home through training what happens in asymmetric thrust conditions.
Yeah.
Evaluate and, where necessary, improve the training and knowledge of flight crews in cockpit resource management in order to prepare them for multiple systems failures, conflicting checklist requirements, and other beyond abnormal situations. So just kind of train for the unusual because this was a very complicated scenario they found themselves in. Expand the information of in-flight emergencies in appropriate guidance material to include advice on how to ensure that pilots and air traffic controllers are aware of the importance to exchange information in case of in-flight emergencies. The use of standard phraseology should be emphasized. So, airline industry is all about standards. Like just make sure that you're using the standard way to talk.
Even in emergencies. Don't shorthand
Even in emergencies.
it.
Yeah. Review design philosophy of fire warning systems to preclude false warnings upon engine separation. So it's like what we talked about. The system didn't know what to do because the engine wasn't there, so it showed a false fire alarm. So it's like review the logic behind these systems to prevent that from happening. Fire resistance of flight data recorder and cockpit voice recorder should be improved. They had some trouble getting the data off of the black boxes in this incident. So they just wanted to make sure. Yeah, they just wanted to make sure they're a little more robust. This is also back in the time, this is 1992, back in the time when they had tape reels in them. So it's a little different nowadays, but still it was it was not quite as reliable back then. The final one is investigate the advantages of installation cameras for external inspection of the airplane from the flight deck.
Oh.
Yeah, I mean, that's not to say to do it, but just like look into it.
Yeah. So you can look and see what the plane looks like without having to,
Cameras like this are a little more common nowadays. I'm not nearly in a position to say this with any authority. I don't think they're mandated, but I think a lot of newer airplanes do come with them installed. And in fact, sometimes when you're a passenger, they'll let passengers see like the camera in the tail. That way you can see the exterior of the plane as you're flying.
Which is cool.
Yeah, which is pretty cool.
I've done that on flights. Be like, oh, look.
For a while, some older planes had that too. I think, we talked about that American Airlines 191 flight from Chicago. I think that plane actually had exterior cameras as well. But obviously, cameras are much improved now. It's much easier to do these kinds of things.
My car still doesn't have a backup cam, but I have an.
I think that's standard now on any car that's made in the United States since I want to say 2018 or 2019.
Yeah. I mean, my car's from 2010, so
so
I have to do the old-fashioned way of turning my head.
My car has a camera. I still turn around. I don't trust that camera when I'm backing up. I still look for myself. So this crash was the deadliest aviation disaster to occur in the Netherlands. And of course, it's because it ended up hitting that apartment complex.
Man, can you imagine if the plane was full? Oh my God.
Yeah, that would have been even way worse. A memorial was built near the crash site with the names of the victims. Flowers are laid at a tree that survived the disaster, referred to as the tree that saw it all.
Oh.
A public memorial is held annually to mark the disaster, and no planes fly over the area for 1 hour out of respect for the victims.
You know what else I think about with disasters like this? Thinking back to the long-term effects of 9/11, like when a building gets hit like this, and the smoke and the debris and the things that are up in the air, how much like the deaths or injuries that might have occurred 10 years down the line from
from inhaling toxic materials. Yeah, I'm sure it happens.
I don't even know how they would even count it. I mean, I'm sure there's...
This doesn't also even count the mental trauma that people in the apartment building lived through, the people who survived, right? Imagine if you lived in that apartment building and you survived. Like, you weren't anywhere, you were on the other side of the apartment, you weren't where it got hit. But imagine, I'm sure you must get like nightmares. Imagine how traumatized you would be for years after that. Anytime you hear like a plane flying over your building. Like, I hear planes all the time where I live. I can't imagine like living through something like this and then wondering every time I hear a plane, like, oh no, is that going to hit again? There's a lot going on here.
And there's always that weird thing. It's like, some people will be perfectly fine, and some people sitting right next to them might die. It's like that. Like, this is different, very, very different. My mom, a year or two ago, was in the shower, or she was watching TV. She got up to go take a shower or something. A tree fell down, split the house down the middle, and landed right on the couch where she was sitting. And she was perfectly fine in the shower, but it's like one of those crazy things where it's like she just been somewhere else in the house at that moment. Yeah,
and I'm sure the same thing probably happened in this incident, right? Like, someone ran out to go to the grocery store, or someone should have been home, and they weren't, and it's like their apartment got hit. It's how do you deal with that? Like, that's something that you can't quantify in a report like this. Like, we talk about the physical injuries, but it's important also, I think, to think about the mental injuries and the problems that people have mentally after this. So after this accident, Boeing issued a service directive to all owners of the 747 regarding its fuse pins. Engines and pylons had to be removed from 747s and the fuse pins examined for defects. And if cracks were present, the pins would be replaced. So, they did this, inspected all the existing ones. And then, like I said, they redesigned the engine pylons. And that's what became in use after that.
Did they backwards, like, update older planes, or just?
Oh, yeah.
Okay.
Yeah, they have to do that. There's no way you could continue flying with the old pylons if they were determined to be defective.
Yeah.
The FAA would issue what's called an Airworthiness Directive, which we've talked about before, where like all operators have to make sure that their planes become updated with the new design by a certain date.
Well, the whole point of having backups is that the backup isn't destroyed by the one that fails.
Right. Yeah. But that's it. That's LL 1862. Like I said, it's the one that people on social media have asked about for quite a while. It's super interesting to me. Just even you were asking, like, the thought exercise of, like, could they have landed this? How bad was it? And God, I just don't think it would have been possible.
Yeah, I see. What I was when I mentioned the flaps, I was thinking, okay, well, if there were no engines, then no flaps, then they moved only on one wing, that would destabilize it more. Yeah. But I didn't think about also the fact, with it going slower. And
which is normally not a problem when the wings are intact and and in one piece. Just that airflow, when it gets disrupted, is terrible. And yet you were correct. I feel maybe I should point that out. The flaps and slats that were associated with hydraulic systems 3 and 4 on the right wing were also damaged, and they didn't fully deploy. And the leading edge was damaged on that wing, so any leading edge control surfaces were also damaged. So they did also deploy. Not as expected, but I think it's just the damage to the wing in general was what the bigger problem was. But that's it. I feel compelled to tell everyone we're going to go on a little break. We're not going to have a new, we go 10 episodes and we take a little break, do some supplemental content, and then come back with new episodes. So we're not going to have a new episode next week, but we'll have supplemental content the week after that, and we'll have a couple of supplemental episodes. And we'll be back with a brand new episode in a couple of weeks when we're done with our little break, our little research break.
And the supplemental episodes, they're gonna be cool too.
They're good, yeah. If you should absolutely check them out. One of the things I worried when we first started this podcast is I worried when we did the supplemental episodes that people wouldn't like them or they wouldn't get as many downloads. But for the most part, they're pretty much the same. I think it seems to me like people still really enjoy them, and they're just as downloaded as our regular episodes, which makes me really happy.
Yeah, thank you for listening to them. Yeah, because I do feel like it's not like they're not good. We still put effort into making the supplemental content. It's just different. It's not as like researched as like, here's this plane. Well, that's not even true. Some of them are as researcch, but it's just a different format. Yeah, is really the way of thinking of it. Yeah, it's all still in the spirit of the podcast, just a little different, a little fun. But we'll have some of that coming up, and we'll be back again real soon. Don't forget, you can check out our link tree. Thank you, Chris. On our social media at Black Box Down Pod. It'll direct you to past supplemental content. It'll direct you to some of our merchandise. We've got a couple of great shirts. We have 2 shirts. I love them both. We've got a couple of mugs, some stickers. Please go check it out. You can check it out directly at store.roosterteeth.com or by checking the link tree in any of our social media. And we saw a lot of people post some pictures on social media and stuff, especially, some of these just came out in like the winter, and it's really cool seeing people promoting the show, supporting the show with merch and stuff.
Yeah, I love it.
Oh, you know what was so cool? A friend of mine was out and saw one of their friends wearing a Black Box Down shirt. I was like, oh, hey.
Really?
Yeah. And then sent me a picture. I was like, hey, my friend's wearing your podcast shirt. I was like,
that's pretty cool.
Yeah.
All right. Well, thanks for listening, everybody. We'll see you soon. Or we'll talk to you soon.
Yeah.
Bye.